Hey guys, welcome back. It's a brand new week and we're starting a new topic in math. I'm really excited about this topic because it's something different from fractions and decimals, and I think we're all ready for a change. A lot of students tell me that shapes and geometry is fun and interesting for them to learn about because we can see so many examples of angles, shapes, and different structures in the world around us. This is going to be our bell ringer for the week. It's not a normal bell ringer. This is actually a practice test from Envisions, and I've posted it in Schoology for you to do. It's in the Monday folder for this week, so Monday, March 22nd. And we're going to do a few problems each day, and then at the end of the week, you can return to the Monday folder and upload all of your written work and your answers and submit it to me. Alternatively, you could also choose to upload your work each day and then submit the final version with everything at the end of the week. It's up to you. What I do not recommend that you do is save this whole document until the end of the week. I am going to require that you take notes along with me while we solve each problem. So this is something you should work on a little bit each day. Okay, so remember I said that I'm going to require you to take notes along with me. This is a skill that is going to really be helpful for you in middle school. When the teacher is writing, you should be writing. So if I'm making marks or notes on the test as we go, or highlighting important words, or defining math terms for you, you should be taking notes on all of that. I want to see this written work when you submit it at the end of the week. Okay, this question asks us, which of the following correctly describes the triangles shown? And it also gives you a heads up that this is the content from lesson 15-2. If you have not completed 15-2 by the end of the week, you need to make sure you do that, okay? 15-2 in Envisions. All right, so let's look at these two triangles and look at our answer choices. Answer choice A. Both triangles have one right angle. Answer choice B. Both triangles have two obtuse angles. Answer choice C. Both triangles have two acute angles. And answer choice D. Both triangles have three acute angles. So we're being asked to do two different things here. One thing that we're being asked to do is identify types of angles. And then the other thing that we're being asked to do is actually count up how many of each type there are. Okay, so let's think about the three types of angles that we can find in these different shapes. The first type of angle that we're going to talk about is a right angle. A right angle is one that is exactly 90 degrees. So a right angle can be shown on a shape by making this notation here. You kind of draw like a little box around the angle. And that indicates, it's like a code that that's a 90-degree angle, okay? Another way to think of a 90-degree angle is you could think of it as the angle inside of an L, and you can find right angles all around you. In the corners of walls, you can find them in your kitchen when you look at the cabinet doors and the angles that the doors and the cabinets make. So that's a right angle. Okay, the next type of angle that we are asked to think about is an obtuse angle. An obtuse angle is one that is larger than 90 degrees. Okay, so even if it's just a teensy-tiny little itty-bitty bit bigger than that 90-degree angle, like a 91-degree angle, is an obtuse angle. And the best way that I know to measure an obtuse angle, oh, that doesn't look right. Hang on, let me try that again. Okay, there we go. So the best way that I know to measure an obtuse angle is to compare it to a 90-degree angle. So if I want to measure this angle here, and I can mark it with this arc, That curved line is called an arc, and that's how I show that that's the angle I'm talking about. If I want to measure that, I can compare it to this 90-degree angle that I showed you here. So when I put this, oh dear, it's got to be on top of it. Hang on. Arrange, bring to front. Will that do it? Yes, okay. When I put it on top of this angle that I showed with the red mark, I can see that it's the 90-degree angle is smaller than my obtuse angle by about this much. Okay? So that tells me that indeed this angle here is an obtuse angle. It's larger than 90 degrees. The last category of angle that is mentioned in this question is acute angles. Acute angles are those that are less than 90 degrees. So even if it's less than 90 degrees by just one little degree, like if it's 89 degrees, it is considered an acute angle. And the memory trick that I use to remember acute angles, I always think of them as being little cute angles. So I can look at this triangle that I drew here, and I can see an acute angle here, and I can also see one here. I can see an acute angle here, and I can see one here. If you ever want to test and see if an angle is acute, you can do the same thing I showed you before, where you can hold a shape that has a right angle in it on top of the shape and see if it's bigger or smaller. Now this is a little bit tricky because this, I can't make this shape rotate the way I would if I was just holding a piece of paper. But I can show you during our live lesson how you would do that with paper, or if you could figure out how to rotate that shape. Okay, so next we're going to look at our answer choices. Let's find one that we can eliminate right away. Looking at answer choice A, I think I can eliminate that one. This triangle does not have a right angle. I don't see that perfectly square 90-degree L shape anywhere. So I'm going to cross that one out. Choice B says that both triangles have two obtuse angles. Well, this one I can see has an obtuse angle right here. Now, what about this one here? I'm actually wondering if that might be yeah, I think this one is an obtuse angle, actually. It's ever so slightly bigger than a 90-degree angle, I think. So I'm going to call that one obtuse. This is a possibility. Because then looking at the other angles, this one is acute, 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 and acute. Those are smaller than 90 degrees. Answer choice C says that both triangles have two acute angles. Okay, so actually this one seems true because this says, answer choice B says, both triangles have two obtuse angles, and that is not the case. Okay, so I can cross that out. It looks like C is going to be my correct answer. Let's just really quickly look at choice D. This says that both triangles have three acute angles. No, we've already determined that they each have one obtuse. Okay, so for this one, we're going to go with C. Okay, let's look at question 2. Remember, when the teacher is writing, you should be writing too. If I'm highlighting important words, you should do the same. If I'm defining math terms, you should do the same. If I'm solving an equation, you should do the same. This tells us that a triangle has angles that measure 55 degrees, 35 degrees, and 90 degrees. Classify, meaning tell what group the triangle belongs to. Classify this triangle by its angles. Let's talk a little bit first about what it means to classify something. I want everyone to copy this definition down. Okay, when you classify something, you tell what group it belongs to. So for example, if we have a whole bunch of kids standing in Miss Lynn's classroom, and some of them are 5th graders and some of them are 4th graders, we could classify those children by their grade level. Some of them would be in the 5th grade group and some of them would be in the 4th grade group. If you wanted to classify different types of fruit, you can put them into groups. Apples in one pile, oranges in another pile. You're going to classify them by putting them into the correct group. When we classify shapes, we're going to name the shape by looking at its attributes. An attribute is something you can observe about the shape, like for example, its angles, okay? So let's draw a triangle that has roughly these angles, 55 degrees and 35 degrees. Those are both acute angles, smaller than 90 degrees, and it has one 90-degree angle. So when I draw that, let's see, where's my shape tool? It's not going to be perfect, right? There's no expectation that you're going to draw an exactly perfect right triangle, but you can draw something that is approximate. So here's my 90-degree angle. This one is approximately 55 degrees, and this one is approximately 35 degrees. This is a right triangle. Any triangle that has at least one 90-degree angle is called a right triangle. If you look at this word, equilateral triangle, this is referring to the length of the sides, not the angles. So this term here refers to all 3 sides being equal. These are terms that you're going to be learning more about in lesson 15-2, so stay tuned for that. Okay, now an obtuse angle is one that has at least one angle, or really only one angle, that is greater than 90 degrees. And an acute triangle is one that has all angles are less than 90 degrees. Okay, let's look at question 3. Which of the following can be used to describe the shape below? Opposite sides are parallel, all angles are obtuse, adjacent sides are parallel, all angles are 90 degrees. Let's talk about what these different math terms mean. Notice that this is content that will be covered in lesson 15-3, so you'll be learning more about this on Wednesday. Okay, parallel lines are lines that are like railroad tracks. They run side by side, and they are always, always, always the same distance apart. They never change their distance away from each other. So it doesn't matter at what point you measure the distance in between the 2 lines, it will always be the same. And the way that you can think about this is by imagining a set of railroad tracks. If the railroad tracks started to like veer towards each other like this, what would happen to the train? You'd have a terrible train crash. In order for the train to be able to run safely, the tracks always need to be the same distance away from each other. Okay, so here I have drawn 2 line segments, and I'm showing that they're line segments by putting these little dots at the end of each line, and they are parallel lines. I can indicate that using this symbol here. If you draw 2 little arrows on the 2 lines that are parallel, it shows that they are the same distance apart at every single point. So I could measure them here, and they would be the same distance apart. I could measure them here, and they should be the same distance apart always. Okay, so when I look at this shape, it does indeed look as though opposite sides are parallel. These 2 sides are the same distance apart. They're not like moving towards each other like that. And then these 2 sides are also parallel. So I can indicate that those are parallel using these symbols. So choice A seems like a good contender. Let's look at choice B. All angles are obtuse. Well, that is just silly. I can clearly see 2 acute angles here and here. So I'm going to get rid of that one. Choice C, adjacent sides are parallel. This word adjacent might be new for some of you. I want everybody to copy it down. Okay, so in geometry, adjacent sides are sides that share a common vertex. The vertex is the point at which the shapes meet. So this is a vertex, and these two sides that I'm highlighting in black are adjacent. This is a vertex, and these two sides are adjacent because they're touching each other at the vertex. This is a vertex, and these two sides are adjacent. So if we look at choice C, that doesn't make sense. Adjacent sides cannot be parallel because they are coming together at a point, and parallel lines never, ever, ever touch or meet. Parallel lines, like railroad tracks, move side by side without ever moving towards each other. So we can eliminate choice C because that just doesn't make any sense. And we can also eliminate choice D because I don't see any 90-degree angles in this shape. So we're going to go with choice A for this one, parallel lines. Okay, remember, when the teacher is writing, you should be writing too. A rhombus is a type of parallelogram. It has 4 equal sides. Whereas a trapezoid only has 1 set of parallel sides. Okay, that's it for today. Join me tomorrow for another exciting video about geometry, shapes, and angles. Okay, let's look at question 4. This quadrilateral has 4 equal sides. What is it? Let's begin by talking about this math term, quadrilateral. Everyone copy this down, please. A quadrilateral is a polygon that has exactly 4 sides, 4 angles, and 4 vertices, or corners. So looking at this shape, I can count 1, 2, 3, 4 sides. I can count 4 vertices or corners, or points where 2 sides meet. Those are the vertices. And I can count 4 angles. Now we need to look more closely at the attributes of this quadrilateral and see which type of quadrilateral it is. Is it a square, a trapezoid, a rhombus, or a rectangle? Look at the shape and think about which items you could eliminate right away. For example, square and rectangle, we can cross those out right away because this shape doesn't appear to have any 90-degree angles at all. I see 2 obtuse angles, and I see 2 acute angles, but I don't see any 90-degree angles. Okay, let's think about whether or not this shape has the attributes of a rhombus. A rhombus is a flat shape with 4 equal straight sides. It's a type of parallelogram. So it has to have equal sides. It looks like the length of each side looks like they're equal. And opposite sides have to be parallel. So these 2 sides are parallel, and these 2 sides are parallel. So it does meet those attributes. Whereas a trapezoid only has 1 set of parallel sides. So in this case, we would choose C, rhombus.